Okay, Joseph, this recording is for you. Since you have Stellarium, it would be faster if you did this yourself. All right, so we are first going to come and open Stellarium. You know how to do that. And we are going to set the place. Here's the little place button over here on this list. I'm going to set the place to Bogota, Colombia, because it's at 4 degrees north latitude. Here we go, Bogota, Colombia. We will update our sense of place. All right, the next thing we're going to do is change these settings down here. So here's the settings button. We're going to take out the atmosphere. It's on this first screen, so it's just dark no matter what time of the day it is. We're going to show the planet markers so we can see their little names. I'm going to go to markings. We're going to turn on the equatorial grid. We're going to turn on the ecliptic. We're going to leave the cardinal points on, and we are going to turn on the equator line. So we have the celestial equator and the ecliptic both marked, plus the equatorial grid. That'll help us find things. Let's show the lines for the constellations and show the labels to give us another sense of place. And then we're going to go here to landscape. I like using ocean just because the trees don't get in my way. All right, that's all we need to do. And we're going to turn this off so that these videos are short. Where's my off button? Oh yes, F10. F10 is off. Okay, Joseph, so we're starting again. Now, I am using the equatorial grid. It's the grid that's based off of the celestial equator because I think it's easier to use when talking about how things move. It's not what astrologers use. We tend to use the ecliptic grid. Trust me, I understand why the astronomers use this one. These lines are right ascension. These other lines that come and look like half circles, these are declination. You can tell we are almost at the equator because the South Pole is just at the bottom of the chart. If we were somewhere else in the middle, we wouldn't be able to see the South Pole at all. It's only when we're on the equator that we can see the South and the North Pole. In fact, we can turn the sky, and there you can see the North Pole, the North Celestial Pole. So this is a grid. It's like being inside the grid lines that we would see normally on the face of the Earth if we were talking about latitude and longitude. They're just projected into space. Okay, so here at Bogota, we are looking at the eastern horizon. Okay? So anywhere, when you look out at the horizon, you're going to see, at the eastern or the western horizon, you're going to see the celestial moving practically directly overhead. So if we were to look up, let's just look up. We can see this equator moving all the way overhead, directly overhead. Looks like it's midday at this time. And we can see it ending in the west. That is because we are, again, at the equator. All right, so let's switch around back to east. Now, we can see the ecliptic line here. We look up again. We can see where the ecliptic line is crossing. This is 0 degrees Aries because it's the spring equinox. And then going the other direction. Okay? So you got to imagine that it's two hula hoops moving together in the sky at a little bit of an angle from each other. In this case, the angle is at 23 degrees. You know all of this. Okay? So let's make the thing move. Click the move button here. Because it's really easy to see this as we are moving through at the equator, okay? We are watching the line of the ecliptic snake north and south above the ecliptic. Going very fast now, so this is just one day. Sun's going to rise and it will be 2 days. Here we go. So you can see the ecliptic is always moving above and below the celestial equator. This is where we get that idea of the dragon snake as it moves around. Back and forth and back and forth. Okay, so you got that idea. And the places where it switches and crosses, the two of them, one's where the sun is, the other one doesn't have a sun because it's the spring equinox, but that's the 0 Aries point and the 0 Libra point. As you can see, the only difference between the two of them is that on one side it's crossing towards the north. Here we go, the Aries point crosses to the north, the Libra point crosses to the south. The Aries point crosses and moves north. The Libra point crosses and moves south. Okay? We're at the equator, so they look exactly the same. But anywhere else on Earth it's going to look exactly the same from the point of view of the ecliptic. The only thing that changes is this horizon angle. That's it. The Earth is still spinning. This angle of the horizon is what's affected by where we are on the planet, not this essential movement that's going back and forth in the sky. No matter where you are on Earth, we are looking at this same movement. We're just looking at it from a slightly different point of view. Okay, let's slow it down a little bit more so we don't have to go zipping by quite so fast. There we go. Okay, now as we are moving, I think I can make it a little faster than that. But there's no intermediate speed. I need an intermediate speed. Okay, so when the ecliptic is on the south side, okay, these are all the southern constellations. So we have Sagittarius, Capricorn, and the rest of them. You know what the southern constellations are. And when it's on the north side of the line, what we have are the northern constellations. So Aries, remember we have the precession of the equinoxes. Just because this says Pisces doesn't mean it's Pisces. It's actually 0 degrees Aries. So here is 0 degrees Taurus. You know, we get over here, we get to 0 degrees Gemini, and so on down the list. 0 degrees Cancer is right about here. All right, so you get this back and forth snaky movement. So let's look at this same day from somewhere else on the planet. Oop, that means I have to turn it off again. So poof, by the magic of technology, we are no longer in Bogota. We are now in Boston, Massachusetts. Okay, so to recap, because we are up here, a little north of 40 degrees, we can no longer see the South Pole in this equatorial grid. But if we turn around, we can see the North Pole up here. So clearly we have moved on the face of the planet. We are at a more northern latitude because the North Pole is high in the sky and the South Pole is invisible. If we could look at the screen sideways, which I don't think we can do here, we would see that the equator, here's the celestial equator, is lower inclined toward the horizon than it was when it was directly overhead. And that's why when we look due east, we see it at this slant. This slant is equivalent to how far north or south of the equator we are. That's how they could use sextants to figure out where the hell we were when we were sailing around in ships across the ocean. Okay, I'm sure you know that part already. So, the confusing part seems to be the movement of the ecliptic. Okay, this ecliptic is making the same back and forth motion as it is when we're standing at the equator. The only difference is that because the limb of the Earth is inclined at an angle, this angle, from where we were before. See all these lines, okay? When we were at the surface, when we were on the surface in Bogota, these were parallel to the ground, if you remember. Now they're all inclined at an angle. So nothing shifted, and this ascendant degree here still has the celestial equator. We're just going to watch the ecliptic shifting back and forth across it, only that our little heads are cattywampus now. So let me turn it on, get it to move, and speed up. All right, see, now we're just moving below again. We're crossing, moving above again. We're crossing and moving below again, just like we were when we were down at the equator. Okay? as you said, the Aries point and the Libra point are just crossing the circle. There is no difference in the way they look, except that one is crossing. When we get to the Aries point, we cross to the north, and when we get to the Libra point, we cross to the south. That's the only difference. Doesn't matter where on Earth we're looking from. In fact, I suggest that we take a little trip up to closer to the North Pole, and you will see it's still moving there. It's just going to be closer to the southern horizon as we do it. So let me take a little pause here, and we'll go look elsewhere. So poof, by the magic of technology, here we are somewhere in the far Northwest Territories of Canada. All right. So you can tell we're near the North Pole because there we go. There's the celestial North Pole way high overhead. And there's the celestial equator way low towards the southern horizon. Okay? Now, when we were in Bogota, this was nearly perpendicular to the horizon. That's the celestial equator. And these are these ones. They go perpendicular, were actually parallel to the horizon. And these lines of declination above and below the celestial equator were almost perpendicular, just like the celestial equator. So we've really tilted our view. Nevertheless, even though the ecliptic is also tilted because we are now looking south, you can almost actually see the entire arc of the celestial equator and the entire arc of the ecliptic if I move my thing in and out. It's still doing this snaking back and forth number. So once again, if we speed it up, so you can see it happening faster over time. It snakes below there's the Aries point right after the spring equinox. Gets to the Libra point and goes below. Gets to the Aries point and goes above. Gets to the Libra point and goes below. This snaking of the ecliptic is what makes the sun disappear from view in these northern hemisphere, this very far north in the winter months. Because the ecliptic where the sun is never rises. The sun is over there on the other side of the ecliptic, part of the ecliptic that never rises, and so it's dark all the time. That's why the sun is up all the time. When the sun is in this part of the sky, then it will be above the horizon all year long. But you can really see the tilt here when we are facing south. As we go around, it no longer looks like it's snaking back and forth in the same way. It looks like it's snaking above and below. I love watching the sky from up here. It's kind of like front row seats. We need to have popcorn.